Hi, hello students, welcome to Let's Understand Physics. In this video, we will see overloading and short circuit for class 10 students from the chapter Magnetic Effects of Electric Current. You have domestic circuit topic. In this, overloading and short circuit are the two faults you are learning in this chapter in the domestic circuit. Domestic means houses. So generally in the houses we have circuit, isn't it? All the electrical appliances in our houses are connected in that particular circuit from the main supply. That you know already. Now, in the houses, you might have observed this one switchboard, isn't it? In the switchboard, you will have switch as well as this one. What is this we call? This is called as socket. Now, why is this socket used? For all the appliances we have like refrigerator, mixer grinder, like that, they will have plug connection, isn't it? This plug we put in this socket. When you on the switch, that particular device will start working. Even your mobile chargers or laptop chargers, all of them will work like this only. They will have plug to charge, isn't it? Now this socket in your house, if you have only one socket, it has particular current rating. It can allow a particular amount of current. Let us take the current it can carry is only 10 ampere. So this socket is useful for connecting any one of the devices at one time. Understood? Now in this only one device will be used for a particular time. For example, if you are charging your mobile, at the same time you cannot connect other device for other purpose. Like if your mobile is getting charged by using this socket, your mom cannot come and use for mixer grinder, isn't it? For that, if at a time you have to use two or more appliances, then what you will do? If you have only one socket, you will go for this. What is this? This we call it as extension box, isn't it? So this extension box will have wire, here you can see, and it has a plug like this. The same plug, if you connect here in this socket, what happens? From one socket, if you observe here, how many sockets are there? In total you have 6 sockets you have. So at a time, how many devices you can use here? You can use 2-3 mobiles, one laptop, one refrigerator, and also one mixer grinder. So total 6 devices at a time you can use. Now this socket is made up of, for what rating? Only 10 ampere, isn't it? Now all these devices will require different currents, isn't it? Yes or no? Now for example, your mobiles, if you are charging 2 mobiles, each mobile requires 5 ampere, and if you are using one laptop, it requires 10 ampere. If your mom using mixer grinder, it uses some 15 ampere. Now I have connected only 4 devices. See how much current I need. 5 plus 5 10, 10 plus 10 20, 20 plus 15 35. Now this 35 ampere current, from where it has to come? It has to come from this socket which is there in your house, isn't it? Now if 35 ampere current is coming from this socket, but is it rated for that much amount of current? No, it is rated only for 10 ampere current. But how much current you are drawing? 35 ampere by connecting more devices. Understood? So here you are drawing extra current by adding extra devices to the socket. So this condition we call it as overloading. So in overloading, what happens? If there are so many high power rated appliances are connected are connected to the same socket, it draws large amount of current from the main supply. This condition is called overloading. Understood? If same current is only 10 ampere is drawing, that means if only two mobiles are connected, then there won't be problem. Understood? But if at all you are connecting high power rated appliances, so many at a time you are using, then that causes excess burden on this socket. Understood? Now that condition we call it as overloading. Okay, I hope everybody understood this. Now as it is drawing excess amount of current, then what happens? The heat produced in the wire will be very large. You know, right? In electricity chapter already you have learnt H is equal to I square RT. So as current value is increasing, heat increases, so that the temperature also increases. So whenever the temperature is increasing on the wire, if you observe, this is plastic coating, isn't it? If you observe this extension box, the wire which is there with the plug, that is plastic wire, isn't it? The coating inside copper will be there, but outer part is plastic only. Due to the excess amount of heat, the plastic coating may get damaged. It will burn. Understood? It will be removed from the wire so that it may start sparkles. Otherwise, it may cause fire in some cases. Okay? So, this is overloading. If so much of amount of current is drawn from the socket, you have to prevent it. So that what you have to do? Prevention methods. You have to not connect so many high power rated appliances at a time to the same socket. If you have different sockets, you have to connect for the different sockets, so that more amount of current in the same socket, it will not draw from the mains. Understood? And the fuse should be connected to the main supply. If there is any problem with this high current, the fuse will first melt and separate these devices from the circuit. If at all the fuse is not melting, then what happens? This high current will pass through the devices and devices also will get damaged. Understood everyone about overloading? And what is the protection? Protection is connecting the fuse in the circuit. Then next one is short circuit. The condition in this short circuit is, you know, you will have two wires, isn't it? Live and neutral. If you observe the socket also, there will be horizontally two spaces. One is for, this is for live and this is for neutral. Understood? You will have earth also. Now we are not learning about that. We are just learning now only phase and neutral. Now you will connect the plug in that phase and neutral. There will be current supply to the device, isn't it? Now accidentally, in the overloading condition itself, we have seen there will be damage on the wire. That plastic coating will be removed, isn't it? Now if the plastic coating is removed accidentally, then if the live and neutral wire come in contact directly means, you know, this is one wire and the other one. If these two are directly contact, that means not the plastic. If the plastic is removed, directly copper is coming in contact, then that condition we call it as short circuit. You might have observed in the sockets, sometimes you use without plug, only wires. Some people will put the wires directly. Okay, now if accidentally the two wires, copper wires, come in contact, what happens? That we call it as short circuit. This short circuit will cause very low resistance. The resistance of the circuit becomes 0. You know, right? Whenever you have circuit, what happens? From the supply, if this is supply, if this is phase and neutral, between that you will have any device like bulb connected. Understood? Now phase wire will carry the current to the bulb, and from the bulb neutral wire will carry the current to the supply. Understood? Now if any problem occurs and the plastic coating is removed from phase and neutral wire and they come in contact like this, okay, then what happens? Will the current pass to the bulb? No, it will not go. It actually always tests for a low resistance path, isn't it? Bulb or any device will have resistance. So whenever the two wires are in contact like this, the current will flow like this only. Understood? In this path, it will not go to the bulb or any device. Now in this case, the resistance of the circuit becomes completely 0 and the current passing will be very large. Then it also causes fire accidents. Understood? Whenever the current passing is very large, what happens? Entire wires insulation, that whatever plastic coating you have, that becomes completely, it will be burnt, and these large currents will pass through the devices and all of them will get damaged and it becomes short circuit. Understood? When the large amount of current passes, it causes short circuit. Even for this condition you can use fuse. Okay, so that whenever the large amount of current is drawn from the supply mains, this fuse will burn and separate the devices from the supply mains. I hope everybody understood this. These are the two conditions where you have to be very careful in the domestic circuit. These are the two faults and we have to use fuse without fail for saving the devices from these overloading and the short circuit situations. Thank you. And I hope all of you understood this video. Please like the video, share to your friends and family, those who are studying class 10, and comment if you have any doubts.